Alright, let's look a little bit more at random walks. In the last video I realized that I've been using size t here, which doesn't make a lot of sense because this is an unsigned type and we want this to be positive and negative. Didn't seem to make a lot of difference using integers instead, which is probably because of the way that casting works in C. But yeah, you should really use integers because we want it to be a signed type. Okay, let's try something. So last video we created something like this, where you have a random walk that is just moving on this grid, which produces interesting patterns like this. But in this video I want to try to make it not move on the grid, but move in any direction. So not just up, down, right and left, but any direction. So before we do that, let's move this code, or rather let's just copy it. So we kind of save it. Let's call it grid walk. And then just change this. So now a point will no longer be just an integer. Let's make it a floating point number. And now let's have a look in Raylib again. So we were using this get random value, but maybe there is which returns an integer, but maybe there's a way to return a float. So let's try to search for random. That doesn't really exist. Okay, so let's make our own random float, and let's say min and max. And we can do something like this, which is using the built-in random function in C, in the C standard library, which actually looks a bit weird. Let's rewrite this. So float of random divided by rand max times max minus min plus min. A little bit easier to read. So suppose this is all right. Let's change this to float and this to float. And then what we want to do is at each step we want to say we'll generate some kind of angle, which will be a random float between 2 and pi. And then let's say we have a fixed radius of just 1, but later on we can also make this a random variable. Then x will be cosine float. I suppose we need to include math.h. So it will be the float, and this will be the sign, and that's it. But actually it should be plus plus what it previously was. So the way we're doing it is we're making a copy of the previous point and then we're adding something to it. So it works like this. Let me see. Let's do this. Didn't work. Okay. I kind of prefer to write it like that. It doesn't really matter. Okay, so now we have a bunch of points. Now we need to plot them. This is all right still. Let's get rid of this guy. And the step size, we'll now make it a float as well. And Let's actually get this one out here, and let's say x1 equals that. This should be y, this should be y, and these two should be 2. And like that. Okay. And then it's x1, y1, x2, y2. And we can compress this one a little bit. So I wonder what will happen when we call draw line with floats instead of integers. Let's have a look at this. Maybe it will just work. Maybe it will just work. There's also all sorts of interesting things like Bezier curves that we could try to do something with. Let's just try. Okay, let me do something else. Let me make the starting point 0, 0 all the time. Okay. Obviously a lot less structured. Let's increase the step size. I mean, it looks interesting, but not as good as before, in my opinion. Maybe we should try to make a zoom thing. Let's say if is key released, key set. Then we're gonna, well, let me see here, key something. Is there a key plus? There is not. Let's make it set, and that will increase the step size, and then X will decrease it. Because then we should be able to do something like this, kind of like zoom in effect. It's a little bit slow, so instead of key released, let's say is key down, and same thing here. And we can also make something to move around. So let's say is key down, key left, or let's make it A. Key A, not sure what happened there. Then we need also some offset, so let's say, let's call it dx, dy, and all of this stuff should just be offset, something like that, and then we'll have standard WASD thing. So probably dx plus something. I'm pretty sure the sign of this stuff will not be correct. But we'll just try it out and see. Okay, up, down, left, down. Okay, so the sign was correct, but it's a bit too slow. Let's make it 5 times faster. Actually, let's make a speed thing. And then here we'll replace this with speed. Still a bit too slow. Let's try 5. A little bit too fast. Okay, perfect. So now we can sort of zoom around and look. When you zoom out, it's also kind of panning a bit, which is unfortunate. But I don't really want to get into that right now. Yeah, I don't know. Let's try reverting it. Like that. Didn't work for some reason. Why didn't that work? Oh, we never assigning, probably. Did I forget that? Yes. Okay, nice. I don't know, there's something about this that just looks cooler in my opinion. What if... Let's make... Let's make this toggle a little bit easier to toggle. Like this. Okay, now we got that stuff. What if we don't generate any angle, but just like some angles? So let's remove that. Let's call it n, so get a random value, and maybe we'll generate 10 different angles, and then we'll say angle is, let's say here n angles is 10. Then we'll say here this is exactly that. Okay, for some reason it's making like this. This kind of right moving thing. Not sure why that is. I feel like that shouldn't be the case. What if we increase this? Still. So it does look like there's some kind of bias. What if I do this? Nice. Okay, so it's because this range is inclusive, so there's technically a higher chance of getting something that's pointing in the right direction, pointing towards the right. There's a little bit too many things going on. Let's try to say just one. Yeah, I don't know. Let's try something like 5. Anyway, what happens if we do this? That's cool. That's cool. Let's make an integer again. Let's try 8, why not? So I don't know. Let's try, just for fun. No, that doesn't look good. Okay, let's think about something interesting to do. Let's try to make this thing a random float as well, between 0 and 10. It's all just one big mess. I'm not sure what to make of this. What do you say, minus 10 to 10? Okay, let's revert it. So let's get rid of these things. Let's do this. And let's say that we'll go between I think it's more or less the same no matter what we do in this case. But I think there are some interesting things we can do. So here the step size, the internal step size is always the same. But perhaps we could change that so it switches modes, you know. So sometimes it's like this and sometimes it's like this. And then it will, if it stays in like this mode for a while, then maybe we'll see it going, having like tendrils like that goes far away. But you know, thinner and happening more often. Yeah, but I think that's gonna do it. Let's try to spread out these things a little bit more. Something like this. Okay, that didn't work quite as I wanted. And why is that? What happened to the red one? Okay, not sure what went wrong. So weird. Because red should be the first one, so I should be 0, which means maybe it's because it said I and not XI. Okay, let's leave it at that for now. In the next one, maybe we'll start to do some 3D stuff. And I will see you then.